So even though the data set may not be what you want to work with, you can find a problem that will get interesting rather quickly. I'm a natural science guy, so a lot of these studies are social science driven, like drug addiction. There's an econ one where you can look at the GDP and stuff of different countries. But me being natural sciences, I was kind of drawn to the Mars crater study. There's over 360,000 craters that have been ID'd on the surface of Mars by a very small group of people. So it's very intimate work as far as who gathered the information. Just kind of has more translatability into the stuff I'll be working with.
Wave patterns.
Well, that's one of the problems I actually just ran into. Was I was going to try to compare some sort of depth to the diameter of the crater to try to make some sort of conclusion based on that, but 80% of the sample study, the crater depth is 0 kilometers. So I guess just from erosion and time passing, they've filled in. So I got to kind of readjust my scope of what I'm going to look at.
Oh, interesting.
My initial question was, is there a relationship between the depth of the crater and the diameter, which is kind of almost self-intuitive, like a larger, bigger impact is going to create a bigger. But I just wanted to see if there was a relationship there, and then maybe compare it with the latitude of where it landed. But one of the things that is very interesting, he has 3 categories that he places each crater in. If you figure out the different cratering patterns, maybe there's some inferences that can be made through that too. You can walk away from a lot of different stats courses and not get anything out of it. But this is actually teaching you software, and not just the software, but the theory and the logic behind the software to generate a question that can be answered. Especially in the sciences, a lot of it is just data analysis and trying to find trends or see what's significant about that data. And being able to get this knowledge rather than just plug and chug a formula is very helpful. Well, it all seems very abstract right now. It's very concrete where we have to get, but just taking all this study and all these different journals and compressing it down into a question that hasn't been asked before, it just seems very, it's very overwhelming. And the gravity of the problem is just kind of weighing on me right now. But with the help of the TAs and stuff, hopefully I'll be able to weed through that and get to the money at the end with the poster presentation. So it's just a little bit heavy now, but once we get there, it'll be worth it, I guess. Just the fact that these data sets have been around, they aren't new data sets, and you have to create an original question is very overwhelming, I guess, is what I've been saying. What if we get to December and we go to present our work and it's just garbage? Like, I don't know, it just isn't, the answer that you were looking for isn't there. Would we still get credit for that poster? And I think that's part of the scientific process and the statistical process, is just going through the work and you have an idea of what it's going to look like and it comes out as something else. That's not a failure, but it's just not what you intended. So hopefully they don't fail us. I don't know. When we first spoke, I didn't quite have my question formulated yet, but I knew, being from the natural science side of the house, I wanted to stick with natural science, and the only data set that really did that was the Mars crater data. So I stuck with the Mars crater data, and after my research paper, narrowed down to a pretty good question, which ultimately took an analysis of several craters that had been known to produce water during the impact event. And I used the characteristics of those craters and compared them to the data set to see how many other craters could potentially have formed water during the impact event, which was kind of interesting. There's a lot of talk in the space race now of getting to Mars, and a big part of that is going to be able to sustain life on Mars, and I think subsurface ice on Mars is going to be key to that survival. So if we can find landing areas on the surface of Mars where we know ice is prevalent, that's just one less thing they'll have to worry about once they touch down in 30, 40, 50 years. a previous study has taken high-resolution images, and it was of the Mojave crater and several craters that surrounded it. And these craters were unique in the fact that there was evidence of running water along the side of the craters. Basically, my hypothesis was that the characteristics that we see afterwards in those craters can be applied across the board, because similar reactions during the impact event are going to have similar results. So the results that I really focused on were a ratio of the crater depth versus the crater diameter and layering around the crater. And the layering is significant because it indicates volatile organic compounds which escape the ejected soil, and it creates a layering effect. Whereas if there are no volatile organic compounds, we'll just have one uniform layer of ejecta. So using those characteristics, I created a sample region, and I wanted to see if the craters within that sample region were significant to those characteristics compared to the general population of craters on Mars. I'm sure NASA has a whole team of people looking for viable landing sites who are all looking at the similar information and similar cratering characteristics. That being said, the idea of crater study is a very important tool for science, but it's becoming outdated now that we have more sophisticated technology around the surface of Mars. So they have much better methods of testing for subsurface ice than just looking at depth versus diameter ratios. So it may just be important to me, but I think the general idea is there for science in general. I think everybody was a little overwhelmed to begin with, just at the scope of what we had to accomplish in 2 to 3 months. You have to write a research paper, you have to put your own original research together, and then you have to present it. So it is intimidating at the beginning of the year, but there's a lot of great resources. We're looking for important signs, I guess, like the p-values and the r-squared values. So when you find something that's significant, that would have to be my aha moment, is you run all this stuff and then maybe you're way off, and then all of a sudden you change some variables around and you have something that might be significant, and that's when you start directing your research and your ultimate question and what leads you to your final presentation. So the whole thing was just a really nice process of trial and error, and eventually I feel like the whole class was a success, but we'll see come Friday.